And this is a lecture or notes activity on 5.7 piecewise functions. Piecewise function is a very specific type of function, a function that will have different pieces for different parts of its domain. All right, so it could be governed by one equation between 0 and 5 for x, and then another equation from 6 to 10. And then maybe another one from 11 to 15. And then, you can keep adding. And this is often useful because in quote unquote real life, as I use air quotes, functions or phenomena that you're trying to describe mathematically don't always obey the same rules for different values. Like the speed of sound in the air is different depending upon the air pressure. So they usually break it up into like certain heights, you have one speed of sound. Then for a different elevation, you have a different speed of sound, and so forth. So they do come in handy. So we're just going to see what they look like, how you can evaluate a function, and really to get you used to how they look. For example, here's a piecewise defined function. I'm just making this up. Let's say f, oh, that's tiny. Let's call this, let's make that about that. Let's say f of x equals, it'll equal 2x plus 3, and where x is between 0 and 5. And then it will be, I don't know, it will be negative x plus 13, plus 18 for all x greater than or equal to 5, but less than 20. All right? And then, that's a piecewise defined function. Notice, you have these are the conditions. Okay? So when these conditions are met by x, that will decide which piece of this function we will use. For example, if I asked you, what is f of 0 per se, looking at our conditions, the equation that is valid for when x is equal to 0 would be the top piece because, that's not working. Because it's or equal to, all right? So, you see what the input is. The input is 0 here, okay? So then we go over to the equation and we look at the conditions and we see that it's this top equation that's valid for when x is equal to 0. So that's what we will put it into, the input of 0. Okay, so this would be 2. Now it's going to be times 0 plus 18. Oh, excuse me. Sorry, plus, it would help if you use the right equation, plus 3. So f of 0, according to this, is 3. You could then ask, what is f of 10? Let's say. Again, we go back to our piecewise defined function, and we see that that 10 is between 5 and 20, so we're going to use the bottom equation to evaluate it. Again, these conditions on the right, these things right here, those tell you which equation to use for a given value of x. So this is going to equal, it'll be negative. Now, x is 20, and it's negative x, so this is going to be 10. And then plus 18. So negative 10 plus 18, that's 8. But that's how you basically evaluate piecewise defined functions. Piecewise defined functions has a given rule, and we usually write it like this, by the way. Put these little curly brackets on it. Will be written as a rule and the condition that x has to meet to use that rule. And then another rule, and with the condition for that piece to be used, and you can keep stacking these up. That is a piecewise defined function in essence. So it's different, but it's really not that hard. Okay, you just got to pay attention to which piece you have to use for a given value. Now, the interesting part is, what happens if I ask you what f of 5 is? Notice, 5 is where the two pieces hand off. All right, so you have to be extra careful when you evaluate this, because you have to decide, do I use this top piece, this piece here, that is valid between 0 and 5 bits, less than 5, or do I use the piece that's defined for when x is equal to 5 and less than 20? Well, the or equal to wins. So since it's the handoff, I always refer to this as the handoff point between the two pieces. So at the handoff point, you have to look for the or equal to. Or equal to is the line underneath. Okay? So we have to use the bottom piece. And that's about the only thing that could trip you up, because you may get confused about which piece to use. Always, if I ask you to evaluate the function at where they hand off, you have to use the piece that's defined there, that has the or equal to. So f of 5 would be the bottom one. So it would be negative 5 plus 18. The opposite of 5 plus 18. That's 13. Okay? And it just so happens that if you use the wrong piece and you use the top piece here, you too would get, if you use this piece and put 5 in, 2 times 5 is 10 plus 3 is 13. You would have gotten the same result, but that's not always the case. It's the case here because this function is what's referred to as continuous. There's no breaks in the graph, all right? But that's a little bit beyond where we are. All right, so that's the idea. So here we go. Levi works in the shipping and handling department of a manufacturing company. Specifically, he works in his dad's company, the Strauss Jean Company. Yes, they named the jeans after him, Levi Strauss. So he earns, here's the key, he earns $18 an hour, which would be considered below minimum wage, I believe, nowadays. But it's $18 per hour. If Levi works more than 40 hours, it is considered overtime. And he earns 1.5 times his hourly wage. Okay? That's a standard way of doing it. If you are a employee that gets paid per hour, if you work more than 40 hours in a week, you'll earn time. It's called time and a half. You may have heard that phrase. All right, that's common. How they administer it could be different. In some jobs, it's if you work more than 8 hours in a day, any time over that will be considered overtime. Or if you work more than 40 hours in a given week, any time over that will be overtime. So in this case, it's per week. So how much does Levi get paid per hour during overtime? Well, it's time and a half. He gets paid $18 normally, and then plus half of 18, which is 18 plus 9, which is $27 per hour during overtime. That's for overtime. Okay? If you were Levi, would you work weekends to reach overtime? Why or why not? That depends on you. Do you need the money? If you needed the money, you would work weekends so you can get to the overtime pay so you can make more money. If you're a kid and you'd rather, or not a kid, but just someone who's doesn't have the need for a lot of money necessarily, you may choose to want to spend your weekends doing your own thing and not earn overtime and just live off the amount you would get paid for a 40-hour week. So it depends on your situation. Personally, I'm all about making more money. So put down what you think. All right, now let H be the number of hours Levi works in a week and WH be his weekly wages. Find W of 15. Well, W of 15 is just going to be, since that's less than 40, that's just going to be his hourly wage, 18 times 15. And 18 times 15 is, what is 18 times 15? I'm trying to do it in my head. I can't. I could go 10 times 15 is 150. 8, no, it's too complicated to do it that way. So I am resulting in going to a calculator, a simple calculator, 18 times 15. And that's going to be $270. Okay? That's how much he would be paid for a 15-hour work week. Now let's find W of 40 hours. What happens if he works a full 40? Well, it's the same exact procedure. W of 40 would be 40 times, or 18 times 40, I should say. Where 18's the hourly wage times the 40 hours. And if you use a calculadora, 18 times 40, you get $720 for a full 40. Isla says that the equation for W can be written as WH equals 18H. Do you agree? Well, that's only if you work between 0 and 40 hours. Yes, if we only work hours from 0 to 40. All right? Write down this. This is what, okay. So W of H is equal to 18H when H is less than or equal to 40. Okay. I noticed I didn't put the lower bound on it because I figured you know that the hours work can't be less than 0. So anyway, that's why on this, it's just H is less than or equal to 40. So now, Levi worked in the first 2 weeks of June. Levi worked 42 hours and 50 hours, respectively. Find W of 42. Well, W of 42 would equal, let's see, it would be 18 times 40, because that's W of 40. That's the answer from B, okay, plus the new rate that we calculate, which was what was it, 27 times 42 minus 40. Okay. 42 is the value that we're asking for. 40 is where it hands off and changes values. Or you could do it in your head and know that that's going to be 42 minus 40. It will be plus 27 times 2. And then we know what 18 times 40 is. 18 times 40 is 720. So W of 42 would be 720 plus 27 times 2. 720 plus 27 times 2 is $774. So he got paid $54 for the 2 hours of extra, time and a half Where if you had paid, worked only within the 40 hours, those 2 hours would have been 36 because 18 times 2 extra. So you see you get paid a little bit extra. So now find f of 50. Well, f of 50 is going to be equal to, or f, I said w of 50. It's going to equal w of 40 plus the 27-hour new fee, right? That's your overtime pay, times how many hours over 40 is 50, and that's 10. Okay, so putting that together, we have 720, because W of 40 doesn't change, plus $270. And if you add that up, that's $990 that you would be paid for working a 50-hour week. Okay. Does Isla's equation give you a correct pay for these weeks? And the answer is no. We have to modify it. Modify, not modified. Modify it, the equation. Okay? So, that means we have a different rule when H is greater than 40, right? We have one rule when H is less than 40, and we have it written up here, the 18H. But when H is greater than 40, we have a different rule. Okay? So use your works from question 3 and 5 to graph W of H. Well, what does that mean? Well, we have to graph the initial, which would be like W of 15 is 18 times 15. Or how about W of 10 is 180? Let's see, where's 180? Here's 10, 180 would be roughly right there. And then we also know that if he doesn't work, it's going to be 0. So there's our 2 points that we could draw a line between. But when we get up to 40 hours, we figured out that W of 40 was 720. So W of 40 is 720. So we basically have a graph of a line that looks something like that. And notice I'm a little bit off of my estimation. So I'm going to make that a little bit bigger. So there we go. All right. And this is regular pay. Now, when we go greater than 40, we are going to have a different line. All right. And we found out that when W of 42 is 774, so I'm going to use a different color. Let's use green. 42 is roughly right here, and it's what did they say, 774, which would be somewhere there, I suppose. Okay, and 990 when we're all the way out to 50. So here's 1,000. Of course, it's going to be right there where I can't do it because I have it covered up. All right, so we have this. $990, and it goes up like that. Okay. So, actually, I probably should just kill it and do it again because I don't like that. So it's going to be, where is 990 at 40? Or no, at 50. 50 990, 50. Okay. It's right there. So now we would have this line. All right, and yes, you can see that rule, but I'll blow it up in a second. Notice we have two different pieces, hence the name piecewise defined. And this green one is the overtime pay. That is when H is greater than 40. And you see right at 40, the graph changes its slope. Hence, it changes its rate, right? It goes from this one, which you can't see because my pen is not working right, to the green. Goes from purple to green. Okay? So so here we go. So we have two pieces. As a matter of fact, we could write WH. Okay, so we have different rules for when H is greater than 40. And we can write the rule for WH to include the overtime. Okay, let me write it over here. Basically, a piecewise defined function is going to have two pieces. So this is going to be W of H is going to equal the 18H for when, and here's the condition, for when H is less than 40 hours. It's going to equal, now this might get a little hairy. Think about what the equation should look like, all right, for the green. Okay, it has a starting point at 720. That's this value right here. And then it has a slope of 27. So writing in piecewise defined fashion, it would be 720 plus 27H minus 40. And that would be valid for H, the condition. You gotta have the condition. That was the condition for the top piece. The bottom condition is going to be when H is between 40 is greater than 40. You can write it like that because there's really, I don't think that you would have I guess if you get up to so many extra overtime hours, they may even bump it to double time. But let's say they don't. Let's say they're kind of cheap. All right. So this would have been your piecewise defined function. Notice I put a curly bracket on it. That's just how we do it. All right. That's just tradition. For piecewise defined functions. Okay, and there you go. All right, don't forget, when you write piecewise, you have to include the conditions at which you use each piece. That's part of the equation. That doesn't come into, you only use it to choose which equation to use, and once you make that choice, you don't have to worry about it, but you have to use it to choose your equation. So a piecewise function can have two or more equations. We saw one with two that apply at different intervals of the domain. So you'll have like equation 1, 2, and 3. That's what this is saying. Interval and domain for each piece. We had 2 in ours. All right. To evaluate, you have to look at what part of the domain the input is in. Is it in the domain for equation 1, for equation 2, 3, 4, whatever it is? Once you figure it out, you take that number and plug it into that piece. All right? And that is the note part of the lesson. Thank you.